Okay. Let's talk about rate and density over here. So you guys are relatively familiar with density. You can use density since it's got a fraction unit to perform unit conversions. You should also make a note of the fact that there's something called a density triangle. The density triangle looks like this. D is in the lower left-hand corner, M is on the top, V is in the bottom right-hand corner. If you're solving for density, cover up the D, and it tells you what equation you should use, which is mass divided by volume. So that means D equals M over V. If you're solving for mass, cover it up, and it says to take density times volume. If you're solving for volume, cover it up, and it says to take mass divided by density. Okay, so do you see how that can be really useful? Okay, now, in number 1, it says that the density of mercury is 13.6 grams per mil. They want the mass of 2.5 liters. My units do not match, right? I've got milliliters here, and I have liters here. So we should probably convert liters to milliliters first, then we can actually do the math and solve for mass, because mass is density times volume. Okay, so if you take 2.5 liters and you convert it into milliliters, where do I put the number 1? Top. That's where the prefix is. Put the power of 10 on the bottom. So you'll divide this out. You're going to end up getting 2,500 milliliters. At this point, since we're solving for mass and you cover up the M and it says to take density times volume, mass equals density times volume. So this is 13.6 times 2,500. That will allow milliliters to cancel, and it will give you grams, which is a unit for mass. So here I got 34,000 grams. Okay. Can I take a look at number 2? Number 2 says the density of lead is 11.2 grams per centimeter cubed. And it says a centimeter cubed and a milliliter are exactly equivalent. This is something that you need to memorize because you will use this a lot in calculations and lab. So 1 centimeter cubed is the same thing as a milliliter. They want to know what the volume in liters is of, how much is that piece of lead?
16.5.
16.5 grams?
Kilograms.
Kilograms, okay. Kilograms and grams are different units, right? So we should convert kilograms to grams first. So 16.5 kilograms into grams. Where do I put the number 1? On the bottom, and then 10 to the third on the top. So this is going to be what? No, wrong one. 16,500 grams. Okay. And then the density of lead, if it is in grams per centimeter cubed, and they want my volume in liters, we can use the density to cancel grams to get to centimeters cubed, and then we can take it from there. So what that means is 11.2 grams, and then 1 centimeter cubed would be here. So I just wrote this fraction for density in a different way to allow me to cancel grams and get to centimeters cubed. Okay, and then since centimeters cubed is the exact same thing as milliliters, I can use it to convert centimeters cubed to milliliters, like that. And then I can convert milliliters to liters, and we're done. So it looks like this. That would be my setup. So it's 16,000 500 divided by 11.2, I can just leave the ones, times second E negative 3, enter. So this is going to be, I need 3 sig figs, 1.47 liters. And the reason you need 3 sig figs is because this is 3, this is 3, this is infinite, 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 and this is 3. Okay. Any questions on that? Okay. Oh no, over here. All right, now we're going to go to unit conversions where we raise the unit to a power. And then let's see what's all after this. Temperature conversions. Okay, so we're going to go right here. Take a look at number 1. Ignore the cubed for a moment. If this was decimeters to centimeters, is that a 1-step or 2-step problem?
2.
Yeah. So we're actually going to convert to meters cubed and then meters cubed to centimeters cubed, okay? Up until this point, you guys have probably never raised conversion factors to an exponent. It's really easy. Let me show you how to do it. If you start with decimeters cubed, you're going to have it on the diagonal, and then you're converting to meters cubed. Where does the number 1 go? Decimeters. Deci is 10 to the negative 1. So you're going to put that here. Okay. We all agree that my unit is cubed, right? So that means you're going to take this power of 10. Oops, that's the wrong one. Take this power of 10 and you will cube it. If you multiply the exponents, this becomes 10 to the negative 3. And then this unit, meters cubed, will come down here. And then we're converting to centimeters cubed. Where do I put the number 1? On the top, next to the prefix. Centi is 10 to the negative 2. What should I do to this power of 10? Yeah. Cube it. And then this becomes what? 10 to the negative 6. You just multiply the exponents together. In your calculator, this will be 4.3 times second E negative 3 divided by second E negative 6. Enter. We started with 2 sig figs. We will end with 2 sig figs because the number 1 and the power of 10 are all exact. So you're going to get 4,300 centimeters cubed. Okay. All right, let's do one more of these. Let's take a look at number 2. All the work that I'm giving you, you're going to use this as a reference when you go to do your homework, okay? So here you've got 14.7 pounds per inches squared. We're going to grams per centimeter squared. Didn't they give us a conversion at the end of the problem, going from grams to pounds? Okay. So since they gave us a conversion, we can use it here. Pounds will go on the diagonal. So these units will match, and then grams will go on top. What number do I put with pounds? Yeah, 1.00. And then the grams is 454. So I just canceled pounds and gave me grams. Then what you can do is, can't I convert inches to centimeters using 1 inch equals 2.54 centimeters, which we learned at the beginning of this section? Okay, so then this unit here and this unit here have to match. So this would be squared, and that means you would have to square the 2.54. Does that make sense? So since these units weren't already raised to a power, but I squared them, you would have to square the number as well. So when you guys go to put this in your calculator, this is going to be 14.7 times 454 divided by 2.54, and then you can use, there's a squared button, isn't there? On your calculator, there's an x squared. So what I would do is I would hit the x squared key, which is on the left-hand side. And then hit enter. And then we want 3 sig figs in our answer. I got 1034. You would make it 1030 grams per centimeter squared. That's 3 sig figs. Somebody's parent calling, maybe. Okay. Any questions for me on that? Then let's turn to the end, which is temperature conversions. Okay, I'm going to let you read this part on temperature. Basically, temperature is a measurement of the intensity of heat. It's the average motion of particles in matter. Heat moves between objects that have different temperatures. So heat is going to move from a warmer object to a cooler object. That's why if you try and touch, let's say, I don't know, something on a stove that's hot, you would burn yourself. And there are different scales for measuring temperature. We are going to be looking at Kelvin, Celsius, and Fahrenheit, okay? Now, in order to convert between the 3 different scales for temperature, you need to know the equations. So I'm going to rewrite these equations. Actually, I already did. I forgot I did. So here it shows you how to convert into degrees Fahrenheit. So you're going to take 1.8 times degrees C, then add 32, and that's degrees Fahrenheit, okay? I usually ask you to round to the nearest whole number. There is a whole separate rule for determining sig figs with these, but we're not going to follow it. And then over here, if you're trying to convert into degrees Celsius, you'll take degrees Fahrenheit minus 32, then divide it by 1.8, and you'll get your answer. For Kelvin, just so you know, there's no such thing as degrees Kelvin. It's just a capital K. So you would take degrees Celsius plus 273 to put it in Kelvin. And then to put it in degrees Celsius, it would be Kelvin minus 273. Okay, let's take a look at the next page at the practice problem that they gave us. I do not give you the equations to perform these unit conversions. You have to memorize them, okay?